Hello everyone, this is Brody Sir again for our 7th part of our weekly practice. And today's topic is plane figures and solids. Now, because there are many difficult words in today's practice, so I do hope you guys first read and memorize all the key terms we've showed you before you really begin to do the questions. All right, now let's start with the first one. The first one asks us to write down the number of the vertices, edges, and faces of the following solids. So the first one would be cube. All right, so what is a cube? A cube looks like this. All right, a cube looks like this. And for the lines we can't see, we draw dotted lines to represent that there is a line here, here, and here. All right, we can't see them, but they exist just on the different side of it. All right, so how many vertices of this cube? We can see clearly that there are 1, 2, 3, 4, 5, 6, 7, and 8. Right, there are 8 vertices. So we just write down an 8 here, or maybe you can say there are 8 vertices. All right, but I'm just write down the number. All right, so now second question about edges. All right, so edges still clear. 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12. So there are 12 edges. All right, we count them down from the top side and those vertical and on the bottom side. All right, so how many faces? I believe this is the simplest question. Of course, there are 6 faces. All right, 6 faces. In the front, in the back, left, right, up, and down. All right, 6 faces. All right, 6 faces. Now, the second solid would be triangular pyramid. Triangular pyramid. So, triangular pyramid looks like this. They have 3 edges. All right, and the bottom looks like a triangle. All right, this is a triangular pyramid. So, how many vertices? Now, we count from the top to the bottom. 1, 2, 3, and 4. Only 4 vertices. All right, so how many edges? 1, 2, 3, 4, 5, 6. 6 edges. And how many faces? We count 1 over here, 1 over here, 1 in the back, 1 in the back, and 1 in the bottom. So 4 faces. All right, 4 faces. So triangular pyramid is also known as the 4 faces. All right, the 4 faces. All right, this is the first question. This is the first question. We just need to draw the solid and count carefully. All right, and now the second question is a little bit more difficult. It's about the property difference between rectangle and trapezium. All right, trapezium. This word is really difficult to pronounce. All right, trapezium. So, rectangle, of course, we are quite familiar, right? Rectangle is like, a rectangle is like this. 4 sides with 4 right angles. I suppose that's why this is called rectangle, but my drawing is poor. Let me do this again, all right? Let me do this again. And this time, maybe a little better. All right, something like this. All right, something like this. And we know that this side is equal to this, and this is equal to this. All right, so this is a rectangle. And what about the trapezium? Trapezium looks like this. We have an upper line, we have a bottom line, and we have 2 sides. All right, we have 2 sides. This is a trapezium. So, we just need to write down 1 property difference, but let me show you maybe 2 or 3 of them, all right? The first one would be the angles. All right, the first one would be the angles. We know that a rectangle has 4 right angles, and trapezium, no. Right, so the angles would be in the rectangle. There will be 4 right angles. All right, I just write it down like this. All right, there are 4 right angles, which means the 4 angles are all 90 degrees. But trapezium, just no. All right, trapezium, no. All right, so the first difference would be about the angles. All right, and the second one would be about the sides. All right, what about the sides? Or we can say the edges. All right, they mean the same thing. So in rectangle here, we have two pairs of equal sides, right? Sides, all right, because this one equals to this and this equals to this. So there are 2 pairs of equal sides, all right, 2 pairs of equal sides. But trapezium, still no. All right, trapezium, still no. Sometimes these 2 lines would be the same. All right, sometimes, not always. All right, but rectangle here, this is always equal to this one. All right, so this is 2 main differences between a rectangle and a trapezium. But of course, these are not the only 2 differences. All right, there are more differences. So just write down the one you want to write. All right, it's the one you prefer. So let's move on to the last one. We need to draw the axis of symmetry of the following figures. All right, so the most important thing here is pay attention when there are more than one axis that satisfy this need. All right, so first one is what we call a rectangle triangle. All right, a rectangle triangle. So we have only one axis of symmetry here. That would be, let's do this with a red pen. All right, and it should be like this. All right, this is the axis of symmetry. And now here we have a square. All right, we have a square. So it means there are many, in fact, many axes of symmetry here. The first one like this, second one like this, and of course we know the third one just like this, and the fourth one just like this. All right, so there are in fact 4 axes that satisfies these requires. All right, and the last one is a star, right? It's a star with 5 points. All right, with 5 edges. So there are 1, 2, 3. Sorry, it goes this way: 3 and 4 and 5. All right, there are 5 axes. So this is the end of today's video, and I hope you guys all get it. I will see you in our next video. Bye bye.